Hi there. This video is all about no work scenarios in which I am doing some amount of force on a system. I am applying a force on a system but doing no work. So I want to consider three scenarios. So this hopefully will be a little bit shorter of a video. Let's consider the first scenario. All right. The first scenario is that I spend 15 minutes standing in my apartment just trying to push on a wall. All right, I'm just going to push on this wall for 15 minutes. How much work have I done? If you're thinking a little bit, right, this video is called No Work Scenarios. I probably have done no work. I've done no work. Why? If I think about this scenario, I'm still using my green pen here. Let's do black pen. If I think about my scenario of a person pushing on this wall and he's kind of straining his back, I don't know what's going on there, but he's not happy. Boo. If he's pushing on this wall for about 15 minutes, has the wall actually moved? If so, get out of that house. It's coming down, right? Presuming that he's in a stable home, that wall shouldn't be moving. And if there's no displacement, right, when I take the dot product for work, F dot delta X, I should get 0, right? Anything multiplied by 0 is 0. Even if the vector is 0, you still get 0. So if there's no displacement of a system, even though there are forces working on it, then there is no work done. All right, so that's our first scenario. Our second scenario, boop, 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 boop. What if I push a heavy box around the perimeter of my room, right? Look at this room, and let's say Susan here is going to push on this box. This is a top-down view, so Susan's just going to push on this thing, and that is going to end right back where it started. Right? How much work did Susan do pushing this heavy box around the room? No work, right? Work equals 0 in this case, and it's for a very similar reason, right? We're saying that F dot our displacement is equal to our work, and so if our displacement is 0, then my work is 0, right? If I end up right where I left off, I have done no work, assuming I have applied a constant force all the way through. And I'm also assuming that that this is a conservative force and not a non-conservative force, right? Friction is doing work all the way through that. And we can talk about that a little bit later. But I have done no net work. No net work. Each one of these legs, right, is some amount of work that I am doing. But if I add them all up, all of these legs add and subtract to get 0. So our third scenario is a little bit more practical, actually. What if I have a force that is constantly perpendicular to my displacement, right? To my displacement. A scenario of this would be something like a force providing centripetal acceleration, right? Force providing centripetal acceleration, if I'm thinking about going around in a circle, I am always going to be moving tangent to this circle, instantaneously at least, right? And I always need to have a force moving radially inward. So I'm going to always set up these perpendicular angles. Well, if F is perpendicular to delta x, right, if I'm thinking about this dot product, I can actually simplify and say F delta x, well, nothing here yet is 0, so we're all okay. But then I plug in cosine of 90 degrees. And we've said in the last video that cosine of 90 degrees is always 0. And so forces that provide centripetal accelerations do no work on the system. Now let's just take a half second back and think about this. Work changes the kinetic energy of a system. Kinetic energy is a scalar, right? It's based on the magnitude of the velocity. So if I'm not changing how fast I'm actually going, but just the direction of how I'm going, that's not doing any work, right? I actually need to speed up or slow down. And we said just going around a circle, uniform circular motion, doesn't actually change the velocity, or I should say the speed of the object in that circle. So delta V remains constant, right, throughout this entire thing. Constant. Which means delta kinetic energy is 0. No work is done. So that's this. No work scenarios. 3 quick no work scenarios. Next time we're going to talk about springs. I'll see you later.